Okay, so we have discussed about the formatting the fields of output, how to control the format of input and output by modifying the default settings by using several qualifiers which are available in the header file of IO manip, input output manipulation. There are several features available like setting the width for a particular quantity, setting the precision of floating point numbers, how much to read and how much to display, and so on. And then what format it needs to be displayed. Do you want to uh, display it in a fixed form or in the floating form, like in scientific notation, and things like that. So, with that, we have more or less covered the basic nuts and bolts of programming. It should be possible to write working programs using these basic constructions, these basic ideas that we have discussed. Essentially, the control flow, which is granted by the standard or the programming language, that is top-down approach. Flow of instruction is top-down. Then you have decision structures, and then you have repetition structures. And with little bit of input-output manipulation, you can get working with writing the basic codes using the standard data types that are available defined in the C++ standard. Now, when you so far we have been discussing uh, taking input from the keyboard, interactive input, and writing output on the video display unit on the screen. Many a times it may be required that you need to run one particular application or program for several different sets of inputs, and then and those different sets of input may be different, may be differing from each other only at one or few places. Most of the input is uh, identical, but some of the parameters may have to be changed. So in that situation, it does not make sense to keep on feeding the input again and again using the keyboard. That is error prone. You can commit error even while uh, punching the keys. Right? So to avoid these kind of errors, and of course it is more efficient if the input can be read from file, and if only one or two few fields have to be changed, you can just edit the file and use that as input. And similarly for output, if you want to preserve the output for a longer term beyond one session, then of course it needs to be preserved in a file, which can be ported, which can be copied, which can be stored in whatever safe location you wish to store. So then you need to go beyond the video display unit, the screen. So typically there are what we have been using the keyboard interface, that is called the standard input. Keyboard interface is the standard input. Video display unit is the standard output. There is also another output which is referred to as standard error, which is also directed to the video display unit. The difference between standard output, which is what you use when you use C out object, that is standard output. There is something called standard error, which is accessible by CERR. CERR. The difference between the two is standard output can be paused. Right? You can go one screenful at a time, and it can be uh, stopped. Right? Not stopped. It can be paused, and then you can resume whenever you need. standard error is flushed. You don't have control. So, and that standard error is usually coming from operating system level, and that is something that cannot wait for anything else. So even if the program is producing some output, and if there is something that is coming on through standard error, that will be overwritten. Standard output will be overwritten. I mean, because both standard output and standard error, they have been mapped to this display unit, so you might get garbled output. But there is a difference between the two. Right? So beyond this standard input, standard output, and standard error, if you wish to read and write from files to and from files, then you need to define a mapping, how to identify, how to tell the computer that input needs to be read from this file and output needs to be written to this file. Right? For that, we need additional facilitation. Beyond the standard input output stream, we also need F stream facilities. F stream is file stream, right? So in addition to IO stream, we need to include the F stream header, which allows us the access to functionalities which are related to defining file streams. Yes. That is not standard C++. Conio.h is header file for Turbo C++. Turbo C++ is not standard C++, right? So, so we will talk about defining file streams, input and output file streams, with reference to this sample code that you see on the screen. So first include is standard IO stream, basic input output stream. Next is F stream. That is, in addition to IO stream, I also need functionalities related to accessing files on the computer. Right? So that is defined by F string. And within F string, and string is just another data type we can have. So string data. For that, for manipulating the string data, we need these functionalities, header file of string. Then we use a standard namespace. Then this standard function definition, master function definition main. So we define this f in as the if stream object. If stream is the data type. What does it mean? If stream is very logical, input file stream. Cin is standard input, that is keyboard. Fin, we will be mapping it to file. So then you don't have to feed from keyboard. The computer will program will read the input from the file, specified file. It can be anything, but you need to read according to whatever is there. Huh. If you are trying to read integer, then obviously the computer expects integer to be there. We'll come to that. We'll come to that. I mean, such types of accidents do not happen. You are protected from that. So, and fin is not a file. Fin is only an identifier. It is only an identifier of fstream type. Ifstream is input file stream. So fin is an identifier of ifstream type. Similarly, fout is an identifier of output file stream type, OF stream. Right? Now, what does that identifier do? What do any identifier do? It contains some value, right? So fin will be mapped to a file. So that is up to me. So I define this fin as an object of input file stream, but I need to assign to fin which file it should read from, or it is mapped to which file. Similarly, fout needs to be assigned, or one particular file needs to be assigned to this object fout, right? Now there can be several ways, and two ways are defined here. Let us deal with the simpler one, which is output.dat. If you want to write the output of the program to a file called output.dat, so you just say fout.open, right? This dot open is a syntax of object-oriented programs using classes, right? So for the time being, we'll come to this class definition and the data data and methods later on. But for the time being, just assume that as a grammar of the way in which a file is to be associated with this object of fout. So if I want the output to be written onto file output.dat, then I need to make that association explicit by saying fout fout.open, and then it will take the arguments, the name of the file which should be listed, right? So this output.dat. So now when I access fout, I am effectively accessing output.dat. So instead of cout, I will use fout. So whenever I write to fout, I will be writing onto output.dat. Similarly, I can map input file in the similar fashion. Let us say input.dat. So I can just say fin.open within arguments, within the quotes, of course, it has to be a string. So it can be just fin like this, right? So this will associate this particular file input.dat with the handle or identifier fin. Subsequently, if I wish to read data, then instead of cin, I would just read it from fin, finx, right? And similarly, I can have fout.open, okay, set w8 x plus y, enter, right? So effectively, we have replaced standard input with a file input, that is input.dat, and standard output with a output file that is called output.dat. It can be anything. Your input file can be anything. Just replace input.dat with the name of that file and replace output file with whatever name you have. But after you are done with your code, your program has done its job. It is important to release this association. fin.close will terminate this association of this identifier fin with this file. So after this statement, I can associate fin with any other file I want, any other input file stream, input file from which the input needs to be read. Similarly, fout association will be closed with one call. So whatever is the existing association of fout with the output.dat file, that will be terminated, and fout will again be a free bird. You can associate it with any other output file if you wish, right? So that's still, I mean, this is the basic idea of how do we create files for reading and writing. Now you asked a question, what happens if I accidentally write onto some file which do not intend to overwrite, right? That was your basic query. So there are certain, I mean, just as this fopen, uh, here we just used the name of the file, that is the simplest possible extension, but there can be several arguments to that, which actually imply which mode the file should be opened. I can open file only in read mode. I can open file only in write mode. I can open a file in append mode. Append mode means the, it will scan through the file, look at all the content that is there in the file, and find a position to start writing onto that file to the next available space, next available content, preserving the existing content. So these are the file opening modes that are normally used. Of course, there are several. You can find out about more file opening modes again in the fstream header file, which will contain more such definitions. So while opening the file to read or write, we can define special attributes which can actually be used as a protection measure so that you do not shoot yourself in the foot. So for example, fout is the fstream object. Fstream is the generic file object. There is a difference. In the previous slide, we were talking about two different objects, ifstream and ofstream. Ifstream was specifically input file stream, ofstream was specifically output file stream. If I'm not sure at the moment or when you're writing the code whether I want to use it as a input file or output file, I can define just a common fstream object, right? So that will be available for use both as input stream and output stream depending on what mode I specify during the opening command, function open. So fstream, fout, I map it to output.dat, and then in addition I define this mapping that it is an output stream, iOS input output system, and then this is the name resolution, scope resolution operator. Right, so this is from iOS namespace, input output stream namespace, and this is out. So that is the output qualifier. So this file is of the type of output stream, and then or it is app. App means it is append mode, right? So that's just to explain this. Uh, Different file opening modes can be combined with bitwise or operator, whichever. And the or operator will again, I mean, all the expressions are evaluated from left to right, and as soon as the final result is arrived at, is known, it stops there, right? It doesn't really need to go all the way to the end of the expression. So the way, I mean, some of these basic opening modes: input in, that is to define the input file stream; out, that is to define the output file stream; app is again another way of defining output file stream that will append to the current file. Out will actually overwrite. If you don't use append, then specifying out only will overwrite the existing contents, right? So ATE is actually what it says: at the end, right? Place the marker at the end of file, right? Trunk, it will overwrite the file. No create. So if you are not sure, if you want to read the data from a specific file but you are not sure exactly what is the name of the file, or if you want to write to output to a file, but you may have some confusion that you do not want to accidentally overwrite to a file which is named similarly, right? So you may specify the specifier qualifier that do not create a file if exact name matching file does not exist. So then the compiler, the program would just flag an error, that there is an error in associating the file with this file object, and the execution would stop. And again, that is something that can help in preventing catastrophe. So again, now that we are talking of files, we can go navigate through the file. We just mentioned about one way of finding, placing the cursor, that is at the end of the file, so ATE. But I can actually go and put the cursor anywhere that I want. Right? That is where you, I mean, if you see, if you are browsing through any document or going through any PDF document, you specify the page number and it goes to that page number. How does it happen? There has to be a marker, there has to be some way to, I mean, it's a single file. You are asking the control to be taken to a particular position in that file. So how does that happen? Right? So there are certain manipulation, certain directives for that, and that is what uh, we do here. So C++ imposes no structure on the file. All files are created for sequential access. So one after the other. Random access files can be simulated using data structures of uniform sizes. So if I wish to go to a particular file, particular access, right, that is another reason. Random access means I can straight away go to whichever point I want to go. Right? This facility was there, has been there in Fortran since the time it was developed in 60s. Huge file, I can specify which point I want to go and I could simply go there. C++ does not do that. C++, in a file that is accessed from C++, you need to go one after the other, sequential manner. That is the only way you can have. But you can actually simulate random access if you know the data type and what is the size of the data. Then you can look at the what is the pointer and what how many offsets you need to give to that particular data point or that particular storage type to go to the whatever storage you are trying to see. So you can actually uh, simulate that. So there are some features available using pointers arithmetic. So you can get a pointer to the current location and then you can seek which pointer, which location you want to go to seek pointer. That is another command. And similar, these can be used to go to the desired place rather quickly instead of going accessing one after the other. I mean, accessing one after the other would be reading data, discarding it, reading another line, discarding it, reading another line, discarding it. That's sequential access, right? So a get pointer is seek G, and that is a long integer type. It takes an argument of long integer type, indicates the position in the file from which next input is to occur. So you can specify where you should read the next data from. Similarly, put pointer, that is seek P, that is the location where you specify where the output should be written to which location, right? So ATE is actually seeking the end of file position, but you can actually seek position anywhere in between the file and you can put the output if that is allowed in while opening the file. File position pointer is an integer value that specifies the location in the file as a number of bytes from the file's starting position. So a file, what is a file? File is only a position in the memory. It points to the some memory address in the storage. So you need to only go certain number of bytes away from that starting point. So you just need to specify what these seek G and seek P uh, functions do is specify the offset from the beginning of the file, and that is what they define the memory location or storage location where the input is to be read from or where the output is to be written, right? And two more functions, tell G and tell P. Again, what is the current position of input and what is the current position in the output file of whatever is the status of input output marker is. So these things will of course be uh, clearer when we discuss the concept of pointers. So far, I mean, some of you might be feeling little uh, lost. What is this pointer? I've been using this word pointer very frequently on this slide. So what is this pointer? Pointer, what do you think pointer should be? Cursor. Okay. Anything else? Mm-hmm. लोकेशन डिफाइन करता है. What am I doing here? I'm pointing, isn't it? So pointer is essentially a position. I'm pointing to a position. So pointer is essentially an address in the storage. Now, pointer can be, it is only an address in the storage, but I can define the pointer of what kind of data it is pointing to. An integer, by definition, would have 2 bytes, right? Signed integer would default length is 2 bytes. So at 2 bytes, if I use a pointer and I define that it is a p is or IP is a pointer to an integer, then it is pointing to one particular location in the storage, but the data that it points to spans 2 bytes from starting from that location. So if I wish to go to the next pointer, next data, that will happen only after 2 bytes from IP. Whatever location IP is pointing to, next data can happen only after 2 bytes. Right? These 2 bytes have been set aside to store the point integer data. So that way, pointers can be used to point to any kind of data. It can point to float, it can point to double, it can point to character, it can point to boolean, and it can also point to composite data type which we define. Users themselves define their own data type based on combination of user defined data type. So every data, every object or every identifier would have some storage associated with it in which data is stored, right? So the pointer only points to the beginning of that storage. And depending on what is the definition of that object, what is the size, storage load requirement of that object, the length is becomes defined. And next data point only becomes available after that offset. Right? So pointer is a very crucial concept in C and C++, and it provides you immense power to do something which might otherwise be not so convenient to do. Right? It may, I mean, other languages you may have to do very weird kind of syntax or very weird kind of constructions to achieve what you can very easily achieve using pointers in C and C++. And now, of course, it is a standard feature in all programming languages. Pointers are a standard feature even in Fortran now. It is a standard feature in Java. It is a standard feature in all other major programming languages that we use these days. So that itself should tell you that it is something, it must be good. That is how everybody is using it. So before we go to pointers, some basic preliminary discussion on the preprocessor and what we use those hash marks for. Right? I had mentioned that when we use include IO stream, this is a C preprocessor directive. Whatever starts with this hash mark in the code, single hash mark, that is considered as a directive to C preprocessor. So how does, what is a C preprocessor? Compilation actually requires that the process of program compilation is code is first run through C preprocessor, and then it is linked, it is sent to the compiler, From the compiler, it is sent to linker, and it is the linker, output of the linker, which gives you the executable code. It is this executable file that you run, right? So when you in code blocks, when you use that build, when you click on that build icon, all these steps actually happen. The code is first run through C preprocessor, and the output of C preprocessor is then directed to the compiler. It is processed by the compiler, C++ compiler. Compiler produces what we call as object files, and those object files are linked with system libraries, whatever system libraries are required, and that job is done by the linker, and output of the linker is what produces this executable file, which is then you execute or run the application, right? So C preprocessor does, when you say include, it does just that. It includes the contents of this file at this location. So this include IO stream, this statement would be replaced by the contents of this file IO stream.h at this location, right? Similarly, if I define include cmath, so contents of cmath header file, those would be included at this point. So after IO stream file, I'll have cmath content, right? So far so good, all is well. But this is not all that C preprocessor does. It is a very powerful tool, and it can be used very effectively to achieve several tasks. For example, if I wish to use value of pi in code, obviously that is going to be a constant, right? So it makes sense to define pi as 3.14159, right? So that if the code encounters any expression of this kind, preprocessor will replace every instance of this pi by 3.14159. So this is what this define pi as 3.14159 does. It defines a constant which you can use in your code, and then at the time of compilation, wherever it finds, C preprocessor finds this instance of characters pi, this pi would be replaced by this number 3.14159. Right? Now, this is a minor detail, but it sometimes, many a times, it is a very useful technique for developing or writing codes which are portable, which are scalable. Right? For example, if I wish to, I mean, some size of the object, if I wish to run some program or some simulation for some size, I might begin with a small size, right? So instead of defining those size in the code, I might define this constant here as a define and let that continue, so that if I wish to scale the code to a larger number, all that I need to do is change this define once, right? And that would be reflected. I don't have to bother about changing that value anywhere in the code, right? So for example, if I wish to define dimensions of an array, right? So let's say int I I size, right? Here I define, now wherever I do, whatever code I use, I don't have to tinker or modify the code inside the code. If I wish to change the array size, I just change this one sentence, one statement here, define directive. I change the I size mapping to 100, from 100 to, maybe I can just say 1000 or 10,000, whatever number I wish to do, and everything will work perfectly fine, right? This works because preprocessor, while running through the code, will replace every instance of I size by this number. So this happens before the code is compiled. The language specifies that the array size should be known at the compile time, right? So if I define this dimension here, like define, then this number is known at the time of compilation, right? So essentially, collection of special statements. These are called directives, preprocessor directives. These can be used for macro substitution. A very another handy example is uh, what could have been used in today's lecture, or probably two parameters, max a and b. Right? This can be defined as if a is greater than b, a or b, using a ternary operator. Right? So in the code, wherever you have max, it will be replaced by this statement. So essentially, it is a ternary operator. It does the returns the maximum of the two arguments that you have. Right? So we can have conditional compilation using if def, if n def. Essentially, it means if something is defined, then do this. If n def means if something is not defined, then do this. Right? So there are several uses for that. You can actually see conditional compilation, very nice examples of conditional compilation, practical examples in the beginning chapter of uh, C++ annotations, CPP annotations by Frank Boken, that is available on the classroom page. So introduction to C++, you will see how that conditional compilation happens using preprocessor directives. So these directives are identified by the hash mark as the first non-white character. These are not program statements, but these are interpreted by read by the preprocessor, C preprocessor, and appropriately replaced. Uh, they are action is taken accordingly by the C preprocessor. Include does exactly what it says. It includes the contents of that file at that location. Define would associate this pattern with this pattern. So all that C preprocessor would do is wherever it comes across this pattern pi, it would replace that pi with this pattern. So this is a symbolic. This defines a symbolic constant pi, which remains defined till the end of the file or until undef releases this definition or association. Undef pi is encountered. So again, macro definition defined using ternary operator, but inline function, that is a relatively recent addition to C++. That is, of course, a better alternative than this uh, macro using preprocessor. Earlier, inline functions were not there, so macro was very handy to deal with such small issues. So we'll stop here. We'll continue with our preprocessor discussion next lecture.